In this lesson, we're going to examine the distance between points in particular. So let's look at something simple. I want to find the distance from A, 0, 0, which is right here, to B, negative 3 and 4. Move that letter. Negative 3 and 4. I want to find how far apart those two dots are. I can do that if I think of this as being a triangle. If I were to complete the lines, I could actually count the number of units. 1, 2, 3, and 1, 2, 3, 4. And then I could figure out this thing by using the idea of Pythagoras. So Pythagoras is a squared plus b squared equals c squared, right? So in our case, 3 squared plus 4 squared equals c squared. Or in other words, 9 plus 16, 25 is c squared. So c is root 25, or in other words, 5. The distance from A to B is 5 units. The nice thing about this idea is it's transferable. That means I can use it anywhere for any points as long as I use it in the same way. So if I want to find the origin point to any other point, I can use the idea of Pythagoras, but I'm going to change it up slightly. Instead of using A, B, and C, I'm going to think of this as there being an x direction, how far along the x-axis I have to go. And I'm going to think of there being a y direction, how far above or below the y-axis do I have to go. So I can change the equation to read x squared plus y squared, and instead of calling it c, let's call it the distance, how long this is. So d squared. And if I think about that, I'm really following the same calculations every time. I'm going to square my numbers, add them together, and then square root it. So let's rearrange that equation, if you will. That's a better version for distance. But there's a limitation to this equation. It only works if I start at the origin. And that's not really valuable to me. So I need to extend this idea just a little bit further. Let's try that. If I want to find the distance between any 2 points, I can use the idea of x squared plus y squared equals d squared, except for I got to figure out how far apart my x values are. In other words, if I want to figure out how far it is from here all the way over here, I got to figure out the difference between my x's. So I'm going to do x2 minus x1. I'm going to do the same thing up here for my y's. The difference between them will be how far apart they are, how long that triangle is. So using Pythagoras, I can use the same idea, x squared plus y squared is d squared, square root it, and I'll get this distance equation. Okay. Be careful, notice that we have minus signs between things. I want to know how far apart the values are, and then plus signs for our Pythagoras idea. It's a pretty easy thing to mess up, putting the signs in the wrong spots. And just to point out distance, you can always call it length too. So we'll try some here. Find the length of the line joining the following points. So I've got an x and a y, an x and a y. My distance equation is big long root sign. x2 minus x1 squared, y2 minus y1 squared. So in our case, we're going to get x2, that'd be the number 7, minus x1 is negative 2 squared, y1, 3, minus 4 squared. And we're going to follow BEDMAS. So inside the brackets, we get 9 squared plus negative 1 squared. And those brackets are important, okay? 9 squared is 81. Negative 1 squared is positive 1. So we end up with the root of 82. And I'd be totally fine if you left it like that. If you really want to punch in your calculator, you can. It's, 9.05. For root 82 is fine for me, too. It's more exact. And you try the next one. Distance from C to D. Square root of negative 12 minus negative 4. 8 minus negative 2. What's that going to give us? In the bracket, we'll get negative 8 squared plus 10 squared, which is 64 plus 100, which is the square root of 164. Or if you want to, 12 point something. What's that? 12 point something. Root 164, or 0.8. Again, if you want to leave it root 164, I'm fine with that. Yeah, that's how we can use our distance equation. Nice and simple. I want to be able to apply this. So, given these three vertices, P, Q, and R, show that the triangle PQR is isosceles. What does that mean? Isosceles means two equal sides. What does it mean by equal? They have to have the same length. Length, well, that's not a word for distance. So I need to find my distances of the sides, the distance between the points. So I got to figure out how far apart PQ are. I got to figure out how far apart it is from Q to R. And I got to figure out how far it is from R back to P again. If I can figure those things out, hopefully two of them are the same. That would be an isosceles triangle then. Let's give it a try. PQ. So 5 minus 1 squared, 7 minus 5 squared. Gives me the root of 4 squared plus 2 squared, which is root 20. That's my first one. Let's try QR. QR, 3 minus 5 squared, 1 minus 7 squared is the root of negative 2 squared and negative 6 squared. If I add that together, I get 4 plus 36 is 40. That's a different one. Yeah, so that's not the matching side. And we'll try RP. So hopefully we'll match one of these two. So RP, 3 minus 1 squared and 1 minus 5 squared. That gives me 2 squared and negative 4 squared. Well, that's 4 plus 16 is 20. Hey, PQ and RP are the same. So my therefore, since the distance PQ is equal to the distance RP, this is isosceles. I've proven that two are the same. And you do have to do all three. I have to prove it's not equilateral. You can't have all three the same. That would be a different kind of triangle. Okay, last question. In a video game, characters are programmed to run up a building at F and head in 3 different directions. After 2 seconds, animal A is at one point, B is at one point, and C is at another point. Which character is the fastest? Well, I can figure out which one's the fastest, which one ran the furthest. I can figure which one ran the furthest by figuring out the distances from F to each of the points. So let's try it. AF. So I'm going to do 22 minus 1 squared and 18 minus negative 1 squared. That's going to give me 21 squared plus 19 squared. Hey, we got to do the stuff underneath the root sign, so don't make it into a 40 squared, okay? 21 squared plus 19 squared is root 802. I don't care what the decimal comes out to. I want to compare. I want to figure which one's bigger. So let's do the next one. BF. BF, beast. Negative 3 minus 1 squared plus 35 minus negative 1 squared. That's going to be negative 4 squared and 36 squared. Into our calculator we go. And I get 1312. Oh, he went a lot further than animal did. And we'll try the third one. CF. CF, I'm going to do 7 minus 1 squared and negative 29 minus negative 1 squared, which would be 6 squared plus negative 28 squared. And that comes out to, into our calculator we go, 820. So which one ran the furthest? Well, obviously the biggest one is 1312, so beast is the fastest. He ran the furthest in the same amount of time. Ooh, fattest. Okay, that's it. That's distance. A pretty simple idea. Okay, try a couple of questions just to make sure you can do them. There's only 4 little questions there today. If you're stuck, come see me.